Hi, this is just a quick video to show you how to add two fractions or two rational expressions that don't have the same denominator. So I'm going to follow the same steps that I would with regular fractions, which is I'm going to factor the denominators, I'm going to look for an LCD, I'm going to build up the fractions using the LCD, and then I'm going to simplify. So the first thing I need to do when presented with any rational expressions is factor the denominator. So I'm going to set up my two factoring x's. I'm looking for the first one for two numbers that will multiply to give me negative 36 and add to give me a positive 5. Alright, so that would be 9 and negative 4. Now I'm going to do it for the second rational expression. I'm going to set up my factor x. I'm looking for two numbers that will multiply to give me negative 27 and add to give me a positive 6. And that would be 9 and negative 3. And often in these problems you'll find that you have factors that match, just like we did. Okay, so now I'm going to rewrite the rational expressions with those new factor denominators. So this is x plus 5, and then this factored to x plus 9, x minus 4, plus x plus 6, all over x plus 9, and x minus 3. Then I'm going to look for what's missing in each denominator. So first, let's make a note of the LCD. The LCD is each one of the factors the most times they appear in a single factorization. So we have x plus 9. That appears at most once in one factorization. We have x minus 4. That appears at most once in each factorization. And we have x minus 3, which also appears at most once in each factorization. So our LCD is x plus 9 times x minus 4 times x minus 3. So going back over to our problem, I can see here I'm missing x minus 3. And here I'm missing x minus 4. So I need to build up each fraction so that it has the missing piece included. So for this fraction, I need to multiply the top and the bottom by the missing piece, x minus 3. So that gives me x plus 5 times x minus 3, because if I multiply it into the denominator, I also have to multiply it into the numerator, which is the fundamental property of fractions. Anything other than 0 multiplied into the numerator and denominator of a fraction results in an equivalent fraction. In other words, as long as I multiply and divide on the top and the bottom the same way, I get essentially the same fraction. This one we said was mixing x minus 4, and the numerator was x plus 6. X minus 4, and then I need to rewrite the denominator with the x minus 4. So I have x plus 9, x minus 4, and x minus 3. Okay, so I have the same thing in the numerator and denominator. Here, and here, and here, and here. Alrighty, and I've also written the denominators consistently. That helps me keep track of what I'm doing as I go, but is not necessary. Okay, so now for the more challenging part of the simplification process is I need to FOIL or multiply each one of these out. So in the first fraction, I need to change colors so we can see what I'm doing. I need to multiply x times x and then x times negative 3. So x times x is x squared, and then minus 3x. Then I'm going to multiply 5 times x and 5 times negative 3. So that gives me a positive 5x and a negative 15. Okay, the same process for the second fraction. I'm going to change colors again so that we can see what I'm doing. I'm going to match the purple because I'm doing the addition right in the middle. So this addition is this addition. Again, this addition is this addition. And now I'm going to write out that second numerator, and I'll do that in another color so that it's easier to follow what we're doing. I need to multiply x times x and x times negative 4. X squared, and I'm sorry, I don't need that parenthesis. X squared and minus 4x. Now I'm going to multiply 6 times x and 6 times negative 4. That gives me a positive 6x and a negative 24. I'm going to rewrite the whole thing over the same denominator. Let me switch back to that purple color because this is all part of the original problem. X plus 9, x minus 4, and x minus 3. The purple hasn't changed between this step and the previous. The green has been multiplied out, and the blue has been multiplied out. And now I need to be able to reduce my fraction. The denominator will stay the same, so we might as well write it in. And in the numerator, I need to combine all my like terms. And I like to cross out my like terms as I combine them because it makes it easier for me to keep track. So I have an x squared and I have a matching x squared. And that gives me 2x squared. Let's see, then I have a negative 3x and a positive 5x. Those would combine to give me a positive 2x. Over here I have a negative 4x and a positive 6x, and those would combine to give me a positive 2x. Okay, so those two simplified will combine to give me a positive 4x down here. And I'm going to see I had a numerator line a fraction line that was way too long. Okay, and now I just have a negative 15 and a negative 24. And those two will combine to give me a negative 39. Alright, the last step would be to see if we can reduce this fraction anyway. And to do that, I would need to use my superstar method because I have a leading term that doesn't have a 1 in front, it has a 2. Here I'd be looking for two numbers that multiply to give me a positive 4, that add to give me a positive 4 and multiply to give me a 2 times negative 39, which would be a negative 78. So I'm looking for factors of 78. And here I would get, alright, so 78, that would factor into 2 and 39, and 39 will factor into 3 and 13. Now I have my list of primes, and I can see that no combination of these primes would get me to 4. So this is not factorable, which means that I've written the completely simplified form of this fraction. I'm just going to write it one more time in a brand new color and stacked properly. That would give me 2x squared plus 4x minus 39, and in the denominator I would have x plus 9, x minus 4, and x minus 3. And you may be asking yourself, can't I multiply those together to make it more simplified? And I would say that the rational expression is more useful in its multiplied out form, in its factored form. So I would leave it like this, and my math lab will accept this as the answer. I hope that helps.